So, okay, welcome to this session entitled When Things Go Wrong, Error Handling in SQL Server. And I need to put the mouse so I can focus on my VM. A quick bit about myself. My name is Erland Sommarskog. I live in Stockholm, where I work as an independent consultant and been an MVP for SQL Server and Data Platform for many years. The way to get in touch with me is by old-fashioned email. You don't find me on any of these funny social media. But SQL@sommarskog.se, and you're more than welcome to drop me a line if you have any questions related to this session or anything else but SQL for that matter. I also maintain a website, Sommarskog.se, which you can see as a small collection of large articles that goes in depth in a couple of topics. And the largest article of them all is called Error and Transaction Handling in SQL Server. As a matter of fact, it's so large that it falls into 3 parts and 3 appendixes, and it's something like 250 pages. What, you say? 250 pages about something as trivial as error handling? You must be crazy. No, I am not crazy, but you will find out in this session what is crazy. Also, slides and scripts for this session is available on my website, sommarskog.se/present. So this is my agenda. The focus is how to handle unexpected error. You may ask, what is an expected error then? Well, an expected error is when you know, okay, this could go wrong, but I do have a plan B. Unfortunately, time does not permit me to discuss that, because if you don't know how to handle the unexpected errors, that is, you'll think your code is running perfectly fine, but it didn't. So that will be our focus. So I'll first discuss what action will SQL Server take when there is an error in your code. How is that affected when, does that change when the setting exactly board is on? Then I will discuss a little bit how your code should react to an unexpected error. Then I will discuss how try catch works in SQL Server. And then I will give you a rationale for how to write catch blocks and like a recipe and a rationale for why you should write them that way. I will discuss a little bit about client-side error handling. And the last thing is how to handle nested procedures and transactions. So SQL Server is running your code and says, oh no, not again. This user, I have to raise an error. SQL Server says, so now is the question, what happens next? Well, let's move into Management Studio. And here I have a script, and I will run this script in its entirety once I press execute. But before that, I'd like to show you what's in this script. The first thing I like to observe you is this go. Most of you probably know this, but just in case, go is not an SQL statement. It is an instruction to Management Studio to split up the script in batches. So when I press execute, Management Studio will send this part to SQL Server, wait for response, then the next thing down to the next go, wait for response, and so on. And this is important to have in mind to understand what we're going to see. Okay, so for the code itself, so I just turn off these one rows affected messages. I drop my test table in case it is there. And I have a test table which is very simple. There's an ID column, a date column, and none of them permit null. There is also an XML column which I use in one case, and it has a primary key. Then there is a procedure called inResp, which starts by printing that it starts a transaction, and it runs an insert statement, which is perfectly normal. There is nothing wrong with this. Keep in mind the XML column is nullable. Then I got an insert statement which tries to insert 3 rows. But we can see this will go wrong because one of the rows has a null. So here will be an error in this case. And there is one more insert statement, again perfectly normal. And if we come down here, we will commit the transaction and print that the inResp has completed. Now, then we have an outResp, which just says outResp starting, runs the inResp and prints that it has completed. The next batch then runs the outResp. And the final batch will check what is the contents of the test table. It will check if there is an open transaction. And if there is, it calls out, after the test, there is an active transaction. And then rolls back the transaction. If there is no open transaction, it more silently says, no transaction is active after the test. So I'm going to run this now. And before I do this, just think a little short while. What do you think? How many rows will there be in the table once I've done my test? Because, well, will there be 0, 1, 2, 3, 4, maybe 5? It couldn't be 5 because this one is wrong. But let's see what happens. So I press execute. And now 2 rows in the table. Some of you might have been thinking there should be 0 rows. And you have a point because transaction is supposed to be atomic. But it's not really the case yet. So anyway, let's see what happens. So it prints inResp starting. Then we got cannot insert the value null into column date column. And etc., etc. The statement has been terminated. inResp completed, outResp completed, and as you've noticed, there are 2 rows in the table and no active transaction. So, as I said, transactions you know, of this ACID concept. A stands for atomic, transactions are supposed to be atomic, but SQL Server violates that case, in this case. However, what is atomic in SQL Server are statements. So here you try to insert 3 rows, one had an error, no rows was inserted. You can try to insert 1 million rows, and just a single one has an error, and no rows will be inserted. However, once this error has occurred, SQL Server says, you know, everyone can have a bad day. I don't want to be the guy that ruins the show, so I want to keep on executing anyway, just to be nice. So that's why we ended up with row 11 and 15 in the table and committed. Okay, so we're going to change now the error. So now it says bad date rather than null. So we might expect this to behave in the same way because it's the same style of error, it's the same kind of severity, but it doesn't. When I run this, we get the error message, conversion failed, will convert in date and or time, but absolutely nothing about no rows in the table and nothing about completed, etc. So in this case, SQL Server said, oh, no. This is a very serious error. We cannot go on. We must stop executing now, and we must roll back the transaction. As I said, you might think this is a kind of the same error, but SQL Server had a different opinion. Okay, let's try something else. So we're going to change the name of the table to no such table. And let's see what happens now. And there's a whole slew of errors. Starting. Invalid object name, no such table. Message 266. Transaction count after execute indicates a mismatching number of begin and commit statements. Previous count 0, current count 1. Outer be completed. And again, message 266. And transaction count after execute, etc. One row in the table. And after the test, there is an active transaction. So what happened in this case is that we came to this statement and SQL Server said, what? This procedure is referring to a table that does not exist. This is a bad procedure. I don't want to run this procedure anymore. But then it says, you know, everyone can have a bad day. I don't want to ruin the show. So it continues the execution in the caller. And the caller has no idea, it's not aware of that transaction that was started in the procedure. So it's left open. And that's why we get that error message about open transactions twice. Now imagine that this happens in a real world application. The user gets this error. Yeah, something went wrong. Okay, continues working and is happy because he can see all the data he has created and so on and so on. His office mates gets more and more irritated because since this transaction is open, he acquires more and more logs, so they are blocked, etc. Then at the end of the day, he closes his laptop and then goes home, and then in the evening he's going to check something and what happened? I mean, I stored all this data. It's gone. Because now when he closed the laptop, the transaction was rolled back eventually. So this is really a nasty situation. And what they were smoking the day they came up with that design, I don't want to know, but it can't be healthy. Oh, well, let's see here now. Let's see. Sorry. We're going to get back with the real name of the table, and we're going to try this one, semicolon-throw. So semicolon-throw raises a user-defined error. It was introduced in SQL 2012, so it's been around for a while. And let's see what happens now. Well, starting. I'm throwing an error. Nothing about completed, so execution was aborted. But this time the transaction was left open. After the test, there is an active transaction. And again, we have this nasty situation with an orphan transaction. Yes. We also have the raise error statement, which actually serves the same purpose. It's just older and has a different syntax. But again, it raises a user-defined error message. Now, when we run this, it's different. Starting, raising an error, completed, 4 rows in the table. So this time execution continued. And the fact there are 4 rows in the table is nothing strange because I have commented out both the bad rows. So although they do the same thing, they don't behave exactly the same. Oops, sorry about that, folks. Oh, wait a minute. This is the right key. But then we have this update statement. And don't try to bother what's on to understand what it's doing. But I'm going to run this and starting, description should never happen. Oops. Message 3624, a system assertion check has failed. Check the SQL Server error log for details, and the message goes on. It's very long. Message 596 cannot continue the execution because the session is in the kill state. And then we have message 0, severe error occurred on the current command. The results of any should be discarded. So this is a bug in SQL Server. And it's a bug that has been fixed a long time ago. I'm running a very, very old build just for the purpose of this demo. what happens in this particular case, they come to some place in the code and think, wait a minute, if we come here, we have done something wrong. And what they do now is they kill the connection because they realize we no longer know what we are doing. Just stop execution to prevent further damage. And that's the essence. If you look in the SQL Server analog, there will be a stack that describes the situation. This is just a generic message that tells you that your session has been killed. Because the level here is 20 or higher, if you get an error message with level 20, it will always cut the connection. Now, this message down here does not come from SQL Server. I think the lowest error number that SQL Server can return is 21. No, this is a message from Management Studio that notices, wait a minute, the connection disappeared, something went wrong. And it tells you that, okay, something went wrong. And if you saw in the results, please ignore them because they are wrong. Okay, let's see. We have one more here to try. That is the wait for statement. So I'm just going to tell it to wait for 1 minute. You might think, what's the point with that? I'm going to talk about the weather now for 1 minute. Let's see what, oh, already now, message -2, execution timeout expired. The timeout elapsed prior to the completion of the command, or the server is not responding. And after the test, there is an active transaction and 1 row in the table. So, wait a minute, we told it to wait for 1 minute. Why did it time out just after a couple of seconds? But wait a minute, this error number here is -2. Again, not an error from SQL Server. Well, the reason we get this is because I've done something which is very rare to do in the Management Studio. I've done this. Oops, let's see. I've gone into Management Studio and say, set the execution time out to 5 seconds. Normally, Management Studio waits forever for a query to complete. However, when you write an application, the default timeout is 30 seconds for most client APIs. So that's when you get this error. And sometimes people see this error, they think that it is your server that is timing out. It is not. It is the application. And what happens now is that the application then, besides raising this error, also sends an attention signal to SQL Server, which tells SQL Server, stop doing what you're doing. And in this case, SQL Server will roll back the current statement, but will leave the transaction open, no matter if it was already open when the batch started, or if it was opened inside the batch. So again, we get this nasty situation with the orphan transaction if we don't handle it. Okay, let's see. Let's go back and restore what you had originally, but we're going to activate this command on top. Set exact abort on, because this is going to change things. Oh, I should point out about the wait for is that another way we can achieve this wait for is this red button over here. Not the wait for, but the attention signal. It has exactly the same effect. It's a human timeout in that case. Okay, so I'm going to run this now. We have the not null error, but now things are different. Starting, cannot insert the value null, and no completed and no rows in the table. So this time with this setting, the batch was aborted and the transaction was rolled back. Now we can try the bad date just for completeness. And we get the same behavior as before. No surprising there. Let's see. We're going to try the no such table. And again, we get the same behavior. We don't get this funny behavior where it stops executing in the caller, which is a very, very strange behavior. Sommarskog row. Again, when exact abort is on, it also rolls back the transaction. So you see, we get a much more consistent behavior with this setting. A lot more consistent behavior, but not fully consistent though. Raise error thinks, no, I don't care about exact abort on. Execution will continue anyway. I'm going to skip the update statement, but there is one interesting thing about this wait for when we have exact abort on. Let's see here now. Just wait a few seconds. And now, when exact abort is on, SQL Server will also roll back the transaction. So again, we avoid this orphan transaction. That's a great thing. Okay, let's go back to the slides to summarize what we have seen. So, the most severe action that SQL Server can take is to close the connection. And this is the default when exact abort is off. The next most severe is to abort the batch and roll back the transaction. It can also abort the batch without rolling back. It can abort the scope, that is the procedure or function, whatever it is, and continue in the caller. And it can roll back just the current statement and continue on the next one. So when does SQL Server choose any of these? Well, close the connection, those are internal errors in SQL Server. You cannot achieve this with the use error. Well, you can if you write some syntaxes or something really silly that SQL Server never fulfill and just got off the rails. That is still a bug in SQL Server. Well, you can do raise error with level 20 to commit suicide, but that's the only thing. But apart from that, those are internal errors in SQL Server. Then this group turns out to be very well defined, abort in the scope and continue in the caller. Those are compilation errors at runtime. Now this sounds a little weird. How can there be compilation errors at runtime? Well, SQL Server has this feature or miss feature known as deferred name resolution. So you might have noticed when I created InResP with the no such table, SQL Server said, I don't care. Maybe that table would appear at runtime. I'm optimistic. But it didn't. So it has to compile that statement where we arrived at it and found, wait a minute, the table is gone. And then that's why we got that error. But it was still a compilation error at runtime. And it will always have the effect that the current scope is aborted and we continue in the caller. Oh, there's some optimization errors that actually can abort the batch, but most of them has the effect of aborting the scope. This group is fairly small, I believe, aborting the batch without rolling back. This group appeared first in SQL 2012 with semicolon throw, errors related to the new feature execute with the result sets, and I've seen it with a few more errors, but it doesn't seem to be that very common. And then we have these two groups, and this is just, as it says, willy-nilly. It's like they're rolling a dice. Okay, if it's an odd number, okay, we're going to abort the batch and roll back the transaction. If it's an even number, we're going to roll back the statement and continue on the next. It's even the case that some result may depend on some set options, not exactly aborted, but different set options. So depending on, I think permission errors will be either one of these or these, depending on ANSI warnings or something like that. Although there are some errors that are in this group that must be here, like deadlocks, running out of this space and things like that. But apart from that, it's just completely willy-nilly and it's a complete mess. Now, the good news is if you turn on exact abort on, things changes because now you only have groups 1 and 2. You don't have 3, 4, and 5 anymore. But unfortunately, though, you get group 6, those that ignore exact abort on. Although it's a fairly small group, the raise error message, which it's one example that we saw, this particular error message 266, tran count mismatch, happens to be one of them. One group you should be aware of is syntax errors. So if you are building dynamic SQL and you do something wrong, exact abort is not going to stop execution because of that syntax error. And there are a few more, like dropping a table that does not exist is also one of these, but it's not a very many, but there are a few. So attention signals. They tell SQL Server to abandon execution, stop doing what you're doing. And it occurs with the client-side error, timeout expired, and it's also generated by that red button in Management Studio. The current statement will always be rolled back, but the transaction is only rolled back if exact abort is on. And now I'd like to also discuss how should we handle unexpected errors in our code. First of all, always display an error message. The user must know that things went wrong. If there are any any data displayed, the user must know that this is nothing to be relied on. Although you may prefer to display a generic error message to the user, something went wrong, please contact system administrator. But because the error message from SQL Server most of the time is going to be Google Doc for the user. But if you do this, you must log the error message somewhere. Never lose it, because else you only know, okay, things went wrong, but you don't know what happened, and it's just completely trying to find in the dark. It's an awful situation. So make sure that you keep the original error message. And you should always roll back any open transaction, because first of all, that's going to prevent incorrect or incomplete data from being persisted. That could be really, really bad, because if you prevent something that is incorrect or incomplete, someone might later on take incorrect business decision from that. And that may also cause even more data errors further on. And also to prevent these orphan transactions that they can cause really big problems in the system. And also, you must abort execution. You have lost control. You no longer know what you're doing, because this is an unexpected error. You did not expect this to happen. So please do not continue. Go back to some safe ground, like clearing all input on the input screen. You don't have to crash the application if you know that, okay, if I go here, I'm safe. but you must return to safe ground so you know where you are. And with exact abort off, which is the default, there is no guarantee that execution will be aborted an error. So therefore, you should always have this statement on the top of your procedures. Set exact abort, comma, no count on. No count has nothing to do with error handling, but it's generally considered best practice anyway, just to prevent these one rows affected, which just causes noise on the wire. Now, this will abort execution for most errors, but not all, but most. And if you're only writing a simple script that you run and you monitor it so you can see what's going on, that might be sufficient. But if you're all writing the application code, you need try catch. So that is what we're going to look into right now. So try catch, this concept exists in many languages. If there is an error in the try block, that transfers execution to the catch block. Let's now look at how that works in SQL Server. So we have the same test table as before. Now the inner procedure has now been changed to have a begin try. But then apart from that, it's the same as before. Down to begin catch, and in the catch block, well, we print that the inner SP raised error, then we commit the transaction, or at least we try to. Now, this is a very, very odd thing to do. It's very rarely you actually do a commit in the catch block. The reason we do it here is to just explore what is going on, but it's a very, very odd thing to do. And we also print inner SP exiting catch handler. Now, this time we're mainly going to run inner SP, and we also print after inner SP. But we still have the outer procedure, which also has a begin try, and the same catch block. So it's the same thing as before, starting calls inner SP, and this one is also the same as before. One good row here, two good rows, and one bad row here, and so on. And then we're going to run the outer SP in one place, and also then we have the same final batch as before. So we're going to run this for the not null error, and we can see starting erased an error, cannot insert the value null into date column, exiting catch handler, and one row in the table. Now, one row in the table here is perfectly normal because we actually, we trapped the error, and in the catch handler, we committed that single row that was uncommitted. Now let's change this to the bad date and see what happens now. There's a whole slew of errors again. Starting, raised error, conversion failed, and so on. Error 3930, the current transaction cannot be committed and cannot support a transaction that writes to the log file. Roll back the transaction. Inner SP exiting catch handler. Message 266. Transaction count after execute indicates a mismatching number of begin and commit statements. Previous count 0, current count 1. And after inner SP, an uncommittable transaction is detected at the end of the batch. The transaction is rolled back. So, what does this mean? Well, it means that the transaction is doomed. And that is also, and the doom means exactly what the message says. That is, this error would have, if we didn't have the catch handler, this error would have aborted the execution and rolled back the transaction. And that's why it dooms the transaction. So we get this message. And the key of this, well, we can't continue this transaction. We cannot write anything more. We can't commit it. We must roll it back. Now, it would have been logical if this error also had aborted execution and rolled back the transaction. But apparently, they threw an even number with the dice when they defined this error. So execution continues for no reason at all. And that's why we get this error about transaction mismatch. But when the batch exits and they realize, wait a minute, here is an open transaction which can't be committed. It's quite useless, isn't it? SQL Server says, and eventually grinds the action, cuts it off the transaction. Okay, let's see here. Let's try something more things. We could try the semicolon throw statement. Yes, let's do that. Starting, raising an error, throwing an error, exiting catch handler, one row in the table. So this error without the catch block would have aborted the batch, but it would not have rolled back the transaction. So therefore, the transaction is not doomed, and we can continue. And let's try raise error. Yeah, the same thing here. Again, this wouldn't have aborted the batch, rolled back the transaction. So the transaction can be committed. It's not doomed. Let's see here now. Let's try this update statement. Can we catch this error? Let's see. No, we cannot. We get the same behavior as before. And this is all right. They have lost control. They should not permit execution to continue. We should not be able to try to catch this because things could go very, very wrong if we did. Let's see here. What about the wait for? Can we catch this timeout condition? Let's see. Let's see if what happens here now. Let's see. No, the same behavior as before. And it's not very strange because we have a catch handler down in SQL Server, but this error occurs up in the client. And of course, we cannot catch those errors that happens in a completely different process. And no, nor can we catch these attention signals. Oh, I forgot the no such table. Oh, let's see. Let's try that one as well. I forgot that one. Yeah, okay. Let's do that one. Let's see what happens now. Okay, starting the valid object name no such table. Transaction message 266. Transaction count after execute. One row in the table. After test, there's an active transaction. And absolutely no sign of any catch handler. So does this mean that we cannot catch these compilation errors at runtime in the catch handler? Well, yes or no. We're going to comment out the quality inverse P, and instead we're going to run the outer procedure. And now, starting, raised an error. Outer SP is exiting catch handler. One row in the table, it was committed, and no transaction active after the test. So these compilation errors at runtime, they cannot be caught in the scope they occurred. Of course, it's quite logical because if you're compiling something, well, if you compile it before you enter the block, of course you cannot. But now we get at runtime, so maybe we of course we should be able to catch this, but it just doesn't work that way, very unfortunately. Okay, so let's restore everything to the starting point now. Let's see here. Yes, and this one as well. And as you, no, I did that. Okay, good. No, this one should be covered out, of course. So, and what we're going to do now, we're going to activate exec board again, and let's see what happens now. So, again, raised error cannot insert the value null into column date column. But now the transaction is doomed. 3930, because we have turned out exec abort on, so this error would have rolled back the transaction if we did not have try catch. So that's, and now also because exec abort is on, this error does actually abort execution and roll back the transaction without we have not to take care of this ourselves. So let's see, we can take the this error, well, same thing as before, the transaction is doomed. Okay, let's see, let's try this semicolon throw them. Yeah, same behavior again here. The exec abort is on, so therefore this error would have rolled back the transaction without try catch, and therefore the transaction is doomed. Okay, but what about raise error? Raise error doesn't care about exec abort on, so now we can expect the transaction to commit, or no. It turns out if exec abort is on, the transaction is always doomed. Always. So to summarize what we have seen, well, when you enter the catch block, the transaction may be doomed and must be rolled back. And errors that roll back the transaction without try catch, those are the dooming errors. And of course, if you get a deadlock running out of disk space, etc., it's perfectly reasonable. There's no reason why you should be able to commit. You should roll back. But for a conversion error, you could have like a plan B, like, okay, if this thing happens, I want to just log this to a table, something like that, but I want to go on with the transaction because this was kind of an expected error. But no, it's not the case. And if you have exec abort on, the transaction is always doomed. And not all errors are catchable, as we saw. So we cannot catch these internal errors that close the connection, but that's perfectly all right, because we should not be able to do that. We cannot catch the compilation errors in the scope they occur, but we can catch them in outer scopes. But often when people try catching SQL Server, they might, produce these errors and see, what doesn't this work? So it's kind of confusing. And I do have a feedback item for this. I have had several feedback items for various sites they've had through the years, and some I've been close with, won't fix it by design. Please, what's the design here? It's just, yeah, a limitation, we could say. Anyway, please download the slides, click on this link, vote for this so they fix this, because of course we should be able to catch all errors. There are a few more errors that cannot be caught. That are various odd things that I did not show, but that typically relates to fringe features, we could call them, like linked servers, CLR, full text. But yeah, they're kind of nasty. And we cannot catch attention signals. Now, let's also discuss how we should use try catch. And try catch is something you should have in almost all user procedures, or in all user procedures, I put almost in parentheses because the exceptions are very, very few. All you're going to see an example of one just in a few minutes, but that's also a very special case, as you would realize. But the example cases where you don't have try catch are very, very few. And keep in mind this, the try block is the main meat. This is where you have your business logic. So that's the main purpose of the procedure. The catch block is always the same in every procedure. And again, almost in parentheses, because sometimes you might have to do extra cleanup in your catch block. For instance, if you, let's say you have taken an application log on session level, then you need to take care of that in the catch block. So you'll release it. But those are special things. But it's almost the same thing you do. So therefore, it should be short and non-intrusive. Only 2 lines. Sometimes I see people posting on forums, well, the try block is this long and the catch block is this long. That doesn't make any sense because you're going to have the code everywhere. So the more you code you have, the more you copy, the bigger the risk is that you change something. So just make it short as possible. So only 2 lines. The first is to roll back any open transaction, and the second is to re-raise the error. And why do we have this? Well, this is the rationale. So first of all, roll back any open transaction. Well, again, as I discussed before, to make sure that you don't persist incorrect data and to avoid orphan transaction. And re-raise the error. Well, an unexpected error must never be dropped on the floor. Sometimes I see people posting on forums, they have the try catch, but they don't re-raise the error, which meaning that they lose the error, which is very, very bad. You must always pass the bucket to the next guy in the call stack. Something went wrong. Don't trust me. Something went wrong. And eventually it floats up to the client. So eventually the error message is displayed to the user, or if it's a batch job or something like that, logged to a table. But it should always be a note of that something went wrong. We don't know what, but something went wrong. Oh, of course we should, something went wrong. Oh, you can tell the user something went wrong, but you must also log so that you know what went wrong so you can fix it. Now, roll back open transaction. So this is the line you should always have. If at a try count greater than 0, roll back transaction. Always have this line. Now, you might say, but I don't have a begin transaction in my code. I don't need this. Well, that could change tomorrow or 2 years later when you have left the company and someone else has taken over your code. Will that person think of, okay, I'm doing a transaction now, so I should maybe I add this line in the cache block. Don't count on that. Add it from the beginning. And also, there is a setting in SQL Server, kind of odd, but implicit transaction. When this setting is on, any email, including select, will start the transaction. And as I said, this sounds very odd for SQL Server people, but it is in fact the ANSI standard. And there are some client API that turns this one on under the covers. So just in case that setting is on, you need to have the rollback in your procedure. And also, you may be calling another procedure that starts a transaction but fails to commit or roll it back. Maybe because it's just poorly written, so the commit is never executed or never reached, but also it could be that, well, it runs into one of, for example, a compilation error at runtime. So it cannot even catch it. Then you might say, well, what if the call has started a transaction? Should I? Yes, you should roll it back, and we will come back to that later on in this session. Okay, so let's now discuss how to re-raise the error. And there's 2 ways to go. You can use a custom procedure, or you can use the Sommarskog throw statement. And we're going to look at both, starting with the custom procedure. So now I've simplified the table a little bit. There's no XML column anymore. Now I've got my error handler SP. This is my custom error handler. And it doesn't have try catch for, well, reasons that are quite obvious. I got extract board, common no code on, though, just as a matter of principle. And then I'm collecting into 6 variables, the values of the 6 functions that gives you information about the error. You get the number of the error, how severe it is, which is, well, 11 to 16 are user-defined errors, and it's just playing with numbers. They're all the same severity, more or less. Error state, which you can say is, well, Microsoft internal. It rarely tells us anything, but just in case it's needed, could help in some cases. And then we collect the name of the procedure where the error occurred, the line number, and the text of the message itself. And then we check, does the message start with 3 asterisks? And if it doesn't start with 3 stars, well, we're going to form an error message that starts with 3 asterisks. We're going to add the procedure name, or if there is no procedure, we say it's dynamic SQL, the line number, the error number, and the text of the message. We're not including the severity and the state because we're using raise error to re-raise the message. And raise error accepts severity and state, so we can put this down here. And you may notice here, I don't put the error message down in here. I only put a placeholder, %s, and put the error message as a parameter. This matters if the error message includes a percentage character to avoid accidents in that case. Then in RSP, this time now with a proper catch handler, and also I've added this statement, set exactly what command now count on before begin try. And why do I have it before begin try? Well, this is not part of your business logic. This is something you always have. So you don't want to see it. When you look at the procedure, you want to look between begin try and end try. So you don't want to see this because it's just noise. The only time you want to see it is if you're doing code review. Oh, wait a minute. This line is missing. Please add it here. But that's the only thing. Okay, begin try. It must be starting. Begin transaction. Now I've changed the error to be really silly. It's 13% for the integer value. Yeah, really silly. That row, again, these three rows, and that this row at the end. Commit if we ever come here. It must be completed. And now a proper catch handler, which does, if it a try count greater than 0, rollback transaction, and then call our error handler SP. And the outer procedure, same thing here. Set exit abort count. Set exit abort command now count on before begin try. Print SP, outer SP starting, call in SP, outer SP completed, end try, begin catch, if it a try count greater than 0, rollback transaction, and call the error handler SP. Most of the time we're going to call the in SP, but we can also call the outer procedure, and the last batch is the same as before. So let's run this. We can see here in SP starting, message 50,000. It will always be 50,000 with raise 0. I can't change that. But level 16, state 1 is authentic. It comes from the actual error. Procedure error handler line 17. I can't change that. It will always be the same line. But the actual message has all the information I needed. In SP, line 12, error 245, conversion failed when converting the varchar value 13% to data type int, and no rows in the table. And if I now change this to call the outer procedure instead. Oops. The output is exactly the same, but it was actually re-raised twice in this error handler SP, but the second time I came here, the error message started with 30%, so it just went to the raise error and re-raised it. Of course, I could have added a stack dump, or sorry, some kind of a stack trace into it, but I did not do that. Now, there are a few problems with this method. One is the fact that with raise error, execution continues on the next statement. And let's say that the calling procedure, I might be called from another procedure, and it's a very old procedure from the days of SQL 2000 and earlier, when we did not have try catch. Or it's just written by some old fart or someone who doesn't understand try catch. So there is a small risk that execution could continue in the caller. And to avoid that, we could use the semicolon throw statement instead to raise the user-defined error. Because semicolon throw will abort execution. And since we have rollback to the transaction, there is no risk there's no problem with orphan transactions. Now, with throw, you can't specify the severity. It's always 16. However, we can specify the error number. So what I'm doing here is I'm adding 50,000 to the severity, because it must be 50,000 or greater. So that I can encode the severity that way. Then it got the error message. The state, though, I can pass. So I'm going to run this, and what? There is no error message at all. Well, so as you may have noticed here with throw, you can't use these parameter placeholders. You can't do that. However, internally, throw still reacts on these parameter placeholders, that is the percentage character, so we need to do this. Yes, we need to do this. We need to make sure that we replace single percentage with a double percent, yes. And now we get the error message. Yeah. This is a serious product. It comes from Microsoft. It's a serious product. Okay. Now there's one more problem with this arrangement, and we will demo this with this backup statement. So if I run this backup statement on its own, you can see here I got two error messages. First, 3201 cannot open the backup device. K such disk operating system error 3. The system cannot find the file path specified. And then message 3013, backup database is terminating abnormally. Just in case I didn't notice that the backup failed, I get this message. Okay, so what happens now if I get this message in try and catch? Well, I only get this message 3013, backup database is terminating abnormally. The other message is lost. Now, this is not very strange because we have these scalar variables. These functions can only return information about one error, and unfortunately, is the error that doesn't tell us anything useful except that the backup failed. Now, this is really bad, but thankfully, most of the time when you get double errors like this is with, well, backup restore, DDL, things you would run as a DBA, but not so much in application code. Okay, then we have the other method, and that is semicolon throw. So we don't have an around SP here, we have an inner SP, and now the catch channel looks like this. We have semicolon throw without any arguments. This form of throw can only be used between begin catch and end catch and tells SQL Server re-erase the error. So I got built-in syntax to do this. So let's see what happens now if I do this. Yeah, I get back the error message as is, exactly as it would have looked like if there had been no try catch at all. That is, of course, very, very nice. And if I, again, I can call the outer SP as well. It's looked the same. Now it was caught once, re-erased, and sorry, it was caught once, re-erased, caught again, and re-erased again. And I get back the same error message. That's very nice. And let's now see what happens with that backup statement, if I have that one. This is also very, very nice. I get both error messages, so I understand what is going. But there are issues with semicolon throw as well. Yeah, you might be thinking, why is it saying semicolon throw all the time? Okay, the normal thing. So in SQL Server, starting with SQL 7, it is starting with SQL Server, you can use semicolon to terminate your statements. Before, the semicolons were not even permitted. And at some point, they deprecated not having semicolons at the end of the statements. But as you see, I have it in a few places, but I'm not consistent because it's not enforced. I'm not spending my time on something which is not enforced. But you might be thinking, the normal thing would be to put it here. I mean, that would be the normal thing. The problem is, if you might be fooling around in the editor like with this, and you might press some key and it accidentally disappears. That could happen. Okay, but you say, but this would still be a syntax error. Well, let's run this and see what happens. Starting. And there's absolutely no error message at all. Absolutely no error message at all. But we can just tell it's starting, but it's not completed. But that's strange. Let's see now if we uncomment that backup statement. We do get an error, but very, very strange. Cannot roll back throw. No transaction of save point of that name was found. Very, very strange. The reason for this is that this means something. This has a meaning, and what it means we're going to see a little later. Thing is, when they introduce new statements and new keywords in SQL Server, they are very, very restrictive to making them reserved keywords. Because if throw had been a reserved keyword, this would have been a syntax error. So, but because that could cause backward compatibility issues, maybe someone has a stop procedure or function called throw, and they don't want to give them a syntax error, so they don't do this. But this case was very, very unfortunate. So this is why I want you to have the semicolon there. I want you to think of this command as semicolon throw. And if you see something like this, wait. Please put the semicolon. You should be very, very nervous. An MVP colleague of mine told me he devised a template for his developers, and he had the semicolon there. But at some point, apparently, that semicolon disappeared. And there are a lot of stop procedures that look like this. So please put the semicolon here. Think of this command as semicolon throw. So we have looked at two ways to re-erase error, and why would you use one or the other? Well, if you still are on these very, very old versions of SQL Server, you have no choice, since semicolon throw was introduced in SQL 2012. But it could also be that you want to log the error or have some other custom behavior in a system that I work with. We did this way before semicolon throw was introduced, so we had to write a custom procedure, but we also logged all errors to a table using a loopback connection, so we make sure they weren't lost. So we can see all the errors that occur in the application. And it avoids the semicolon trap. But semicolon throw also has its advantages. I mean, it's simple. You don't have to write an extra procedure. It's very, very nice. You just put it in and it works. And all error messages are preserved as is. That is also very, very nice. And it makes sure that execution is aborted, although you can achieve this with a custom procedure as well, as you saw. Now, okay, I have try catch in my procedure. Do I still need to execute abort on? Yes, you do, because try catch does not catch all errors, and it does not catch the attention signals timeout expired. So yes, you should still have execute abort on to make sure, reduce the risk for orphan transactions. Now, I'd like to talk a little bit about client-side error handling. So all call you make to SQL Server should be checked for error And if there is an error from SQL Server, you should always respond with if at a tran count greater than 0, rollback transaction. Errors from SQL Server, including very much timeout expired. So you make sure there is no orphan transaction. The one exception for this is if you have started the transaction from your own from a transaction object, then of course you should use that transaction object. Don't rely on that the SQL code actually have exit abort on. Each component should do its job, and it could be the case that, well, the SQL code, even if it has exit abort on, it could be, well, it has begin transaction, but the programmer forgot to commit or had it, well, some part where it commit was not executed, in which case exit abort is not going to help. So in SQL Server, each component should do its job, and that includes covering up for the other guy because, well, things are a bit primitive. Then there's one thing more I want to say, and that is make sure you get all result sets. And I'm going to explain what I mean by this by looking at this small demo in C#. So here I've got a batch text, and this batch is designed so that it's going to return a couple of rows, but then we find a max column where max length is -1, we will get a runtime error. Here's my main procedure. I open a connection, open a command, I use a data reader, and all I do here now is counting rows. But I'm thinking, I know that my query only returns one result set, so I'm not going to call next result. I don't need that. Print the number of rows read. I got an exception handler, and yes, I submit in reaction of an error if at a tran count greater than 0, rollback transaction, and I print out the error that occurred. So let's compile and run this. Error in the valid floating point operation occurred. Okay, so let's see. Let's now go up and oops, sorry about that, folks. Okay. Now, of course, you would never submit anything like this. This is just would be silly. But just imagine, this is only to keep the demo short, but just imagine that instead of the batch text, it's a call to this procedure, sorry, to this statement, you're calling a stop procedure that does a lot of things, and at the end it has this select statement, which could produce an error at runtime. Now let's see what happens when I run this. 60 rows read. The error was completely lost. And the reason it was lost was because previously the error occurred as part of the statement, but now this statement completed and it was still instead raised by this statement. And because how things work on the TTS stack, it now is hidden in the next result set. Now think of this for a while. Let's say that this is a report and we show this 60 rows to the user and the user says, the company is doing really great. It's doing really good. We can make some acquisitions. When in fact, if the user had seen that 61st row, he would have realized, oh, wait a minute, we need to cut down. We have to be defensive for a while to make sure we don't, So now what happens is the company goes on a shopping craze and goes bust and you lose your job. Sorry, oops, that was the wrong key. But this is what I'm going to uncomment this row now with getting the next result, because this is where the error is hiding. And now I get back the error message and a valid floating point operation occurred. So this is the virtue of getting all result sets. So as we saw here, that with execute reader, always use next result to get through all result sets. Never assume that, I only get one result. No, you always need to use next result to make sure that you get all errors that occur. If you're running execute scalar under the covers, it will only get the first result set, but normally you would only use execute scalar to get one scalar value. So I don't think the risk is for an error, for an actually hiding an error is really very likely here. Our execute non-query will never return any result sets to the caller. However, under the covers, it will get all the result sets and discard them and raise any errors, so nothing will go wrong here. If you do a data adaptive fill with a data set, same thing here, of course, it's going to fill up the data set, so it's going to go to the end of the result set. But this is the nasty one, data adaptive fill with a data table. And thinking, okay, we're only going to fill up with one data table. We only care about the first result set. So here you can miss errors because they occurred during the select statement. Now, there is a workaround for this. Instead, do this data table load with an SQL data readers argument. It has the same purpose as the previous one, but this one will actually get all the results and all the errors. So the last thing I want to talk about is nested transactions and nested procedures. So let's say doing this, begin transaction. I can see someone has posted something quite long in the, is that a question or no? That's only Justin. So I have my screen with the Teams channel a little bit away from me, so I can't read it from where I stand. Well, it's actually written. I can't really see that it's something there. Anyway, so I do this begin transaction and the transaction starts. If I now say begin transaction again, which I might do because I'm in an inner procedure, well, it will increment at a train count. If I now say commit transaction, that will commit nothing at all. It only serves to decrement at a train count. Now, when I do commit once more, so I come down to 0, this is when the transaction actually commits. Now, if I do rollback transaction, well, it doesn't matter if I do it here, here, or here. Everything will be rolled back. Everything. Okay, let's now think about nested procedures. So we have an outer procedure that starts a transaction, and it calls an inner procedure that also starts a transaction, because that inner procedure is intended to be called on its own. Well, should really the catch handle of the inner procedure roll back everything? And ideally, no, because that outer procedure may have a plan B. Okay, I know that this procedure could go wrong, but in that case, I'm just going to log an error to a table, mark this customer as invalid or whatever, and move on in my loop, whatever it has, and so on. But keep my transaction. Ideally, yes, we should not roll it back. However, we are not in Oracle, we are not in Postgres, we are not in MySQL, we are in goddamn SQL Server, and we have no other choice, because this is so primitive. We must roll back the transaction, because SQL Server does not offer anything better. The inner procedure has failed to fulfill its contract, so it's out of the question to continue. We must roll back. At this point, someone might send you a private chat message and say, psst, you can use save points. So yes, I need to talk about save points then. Yes, you can do this in SQL Server. You can say begin transaction, my save, and do the first part. Then you can say save transaction. Yeah, and you can also say give the transaction a name, yes. You can say save transaction, my save, and you must have a name here. Do the second part. Now you can say roll back transaction, my save, and the second part will roll back, but the first part will still be there, will still be open, still be committable. And by the way, the name of that save point could be throw, so that's why rollback transaction throw is legal syntax. And of course, they should have outlawed this. They should have just said, no. Even if there's a backwards compatibility issue, don't permit this. But they didn't. Now, this sounds like something that could be very useful for what I'm talking about in the previous slide. Now, save points are useless. Why? Because you cannot roll back to a save point when the transaction is doomed. And I've told you to run with extract abort on, in which case the transaction is always doomed. And even if you didn't listen to me and run with extract abort off, well, you can still only roll back on Sundays, Wednesdays, and Thursdays, because there are only some errors for which you can roll back. For some errors, the transaction will be doomed anyway. And if you're going to try to deal with save points, you will have to, well, first check when you come into the procedure, do you have an open transaction, and add this to your catch handler. I mean, the error handling will be more complex for a limited benefit. The risk is only bigger that you introduce an error into your catch handler. And if you have an error in your error handling, that can mask the original error, in which case you don't know what went wrong. And you're still here in a dark room, well, something went wrong in the application, but I don't know what. Also, save points are not supported in distributed transactions. You may say, but I'm not using distributed transactions. Look, you don't know. Someone could get the idea 3 years from now to call your procedure in a distributed transaction. As a matter of fact, I've used save points very few situations in my career. Actually, I did see an example of using a save point this week, not in error handling, but my colleague wanted in one place, okay, we need to fake that we have some data on these tables so we can call this procedure to get some data. So he inserts some rows in the table, and then he rolls back. And in case there is inside of a transaction, he actually uses a save point. It has nothing to do with error handling. But I actually did try to use save points in an error handling exactly for this purpose. And that procedure was called in a distributed transaction. And it was horrible because the error message was just like, it told us nothing useful. We had to use Profiler to find the root cause, which I think was, as a matter of fact, my save point inside that distributed transaction. So no, they're not useful at all. Okay, so coming towards the end of this session, and I'd like to do a summary in terms of aims and means, what I have been talking about. So always communicate unexpected errors. Never allow users to think that they see they see correct data. That could lead to incorrect business decisions, which can be very, very bad. And the means to do this is to re-raise the error and to get all result sets. Always abort execution on unexpected errors. Never persist incorrect data that could have even graver consequences. And set exit abort on if in a try count greater than 0, rollback transaction, and re-raise the error. Prevent orphan transactions. They're just so horrible. I've been through this a couple of times in my career, and it's an awful situation until you understand what is going on. Set exit abort on if in a try count greater than 0, rollback transaction, also in the client count. And never lose the real error message. Without it, troubleshooting is so difficult. I've been through this more than once in my career. You just say, oh, something went wrong, and you have no idea what. And you, oh, it might be this, it might be this, it might be this. And then when you eventually get hold of the real error message, oh, yeah, okay, of course. And it's a 10-minute fix. Keep things simple. Don't do fancy error handling. And watch out for the Sommarskog trap. Okay, yeah, this one more thing, yes. Management Studio, you can go into Tools, Option, Query Execution, Advanced, and say that you want to have exec abort on by default when you connect to SQL Server. I very much recommend to having this, checking this option, because one thing that can happen if you don't have this is that, well, you run some piece of code and, well, you run maybe you press the red button, but there is a transaction open, but you don't think about it. So you continue doing things, and eventually you get a batch and transaction aborting error. And now everything is rolled back, and you get very confused because, wait a minute, what happened? I changed the procedure, what? And so on and so on and so on. Because you have been working inside of a transaction for the last 50 minutes that was rolled back. Avoid this situation with having exec abort on by default. So that was all I wanted to say. My name is Erland Sommarskog. My email address is skl@sommarskog.se, and you'll find slides and scripts on my website, sommarskog.se/present. And if you want to take part of, we'll read 3 parts or 3 appendixes, you can start here with part 1, which is fairly short. It's only like, I think, 12 pages. It just gives you recipes for writing an error handler without talking much about the gory details. The part 2 goes on and discusses what can happen in case of an error, including some weird things I didn't include in this session. Part 3 is even longer. I think it's 100 pages, but that is also because it includes quite a bit of code. One very versatile error handling where we can log the error message into a table through a CLR loopback, and also a longer error handling example. And then there are 3 appendixes, one for linked server, which I can assure you, going to take your head spinning to the next level, because that's so confusing. The CLR is also some interesting error things that can happen there. The last appendix, it's not so confusing. It just extends the error handling example in part 3 to use it particularly with service broker. So I managed to complete a little bit ahead of time. But if we have any questions, do we have that, Justin? Or anyone has any questions now, you're more than welcome. Either in the chat or
so far. No, thank you, Erland. That was a very comprehensive look at that. It was quite a lot of content in that hour.
Oh yeah, I tend to put a lot of content in my sessions because everything is so important.
Yes,
and maybe I think it went a little bit. When I rehearsed this, I ran over a little bit, so I think I need to keep some tempo. Maybe, yeah. I'm sorry about that, folks, but yeah.
No, it's I mean, like, I guess the advantage of us, so because we now publish into YouTube, we can always go back, pause, and you know, see what, pause when needed. So I try and drop the links in the chat as we go. One of I couldn't seem to find that. Feedback. It seemed to go to a dead URL, but I don't know.
That's bad. That's bad.
Whether that was me, you were saying about voting for the improvement on.
Let's see.
That one, yeah. No, unless it was my.
Copy link. Let's do that. Page not found. Yeah. That's bad.
So they're taking it away. Oh, well.
Yeah, that's also weird. I've never seen that page not found before.
Yeah. There we go.
Well, sorry about that, folks. I need to.
Oh, that's okay. I just letting you know, because I did Google, and I can see you put it on a forum post somewhere as well, that URL. But yeah, it doesn't seem to to exist anymore or
Now,
something.
maybe it's never in the deck, or let's see here if I can. I don't know. We should take up. It's probably an article somewhere, but let's not take up time with this here. So
look, thank you very much.
Well, I think it's a bunch of speakers coming on up in 10 minutes, and people probably want some break. So I just want to say goodbye and thank you everyone for listening.